All right, welcome to lesson 8.2. Before getting into new stuff today, I wanted to give you two review questions, I guess, about direct and inverse variation. Remember the two equations. Direct variation is just a fixed amount, like you make $12 per hour, so like 12 times x. And an inverse is a constant amount, k, divided by x. So you have 30 pieces of pizza and you divide it by however many people come, right? That's an inverse, is k over x. So pause the video and see if you remember how to figure this out. Okay, so the trick for figuring it out is I always start by multiplying x and y and see if that comes out as the same. So here I get 6, 6, 6, and then 0.4 times 15, I believe that's 6 also. Okay, so basically we can say that x times y equals 6. Okay, and then that's like the right equation. Sometimes students struggle with which type it is. So some tricks for that. One is as x goes up, on this side x increases, the y values are going down, right? So that's a sign that it's inverse. Okay, the other way I like to do actually is just solve this for y. So I'm going to divide by x. So I say y is equal to 6 over x, and that's a sign that it's inverse. And that's what it means to be inverse, is some fixed amount over x. That's kind of how I like to do it, but you can do it however you want. So let's try the other one. So I'm going to try that multiply them together trick, but I won't get the same number here. So I get 45, and then I get 125 here. So basically that's already not working. All right, so let's try the other one where I divide them. So let's try doing y over x. Okay, so I have negative 15 over negative 3. And I'll compare that to 25 over 5. So far, those are both 5. 30 over 6, that's still 5. And then 80 over 16 is still 5. Okay, so basically we did y divided by x and always got 5. Okay, and so again, if I write it as y alone and multiply both sides by x, I would have y equals 5 times x. Okay, and that's our example of direct. Right? That's like you make $5 per hour or something like that. Again, another way that you can tell is that as x goes up here, y is also going up. So that's a sign that it is they're going together. There's a direct variation between x and y. They're both going up together. Sorry for the bad handwriting here. Okay, so what we're going to do today is we're going to graph inverse functions. So basically, we're going to do our k over x function. We're just going to do the graph, and we're going to shift it around a little bit, talk about something called asymptotes, but more or less it's going to be graphing in this section. Okay, so first thing is I want to get down a quick definition of this word asymptote. It's actually one of my favorite words. When I think about naming kids, I've thought Prowl would always be a good name, but I also think Asymptote would be kind of a good name. They could go by like Tote for short or something like that. Anyway, so an asymptote is a line that the graph approaches but never reaches. Okay, so I think of this as like Mr. Westphal's dream of dunking a basketball. In college, I got close and close and close to dunking it, but I never was able to actually dunk a basketball. Okay, so graphically, what an asymptote will look like is these inverse graphs will kind of look like this, right? They'll kind of have this weird shape. And so what happens is you can draw a line, like if I draw a picture or a line through the middle of this quick, right? The graph gets closer and closer to that. Maybe I'll make it a different color, that red line, but it never reaches it. Okay, so that's considered an asymptote. And I didn't draw it super well because it kind of curves up there, but really what it looks like is it gets closer and closer but never reaches it. Okay, so maybe I'll draw this a little bit better here. Right, it gets close, 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 but never actually reaches it. That's called an asymptote. Okay, and there's technically two types, so that would be an example of a horizontal asymptote. Okay, so you might want to label this in the picture. And then you could also have a vertical one. So I might have to alter my picture here a little bit, but you have one that goes straight up and down like that. Okay, and that would be called a vertical asymptote. So maybe I'll redraw the graph here. I redrew it a little bit here, but the vertical asymptote, this green line on both sides getting really close to but never crossing it. Okay, that's called just a vertical asymptote, right? Because it goes up and down. The equation for these lines, they're kind of special equations, but an up and down line here, that equation for that vertical asymptote is just x equals -2. That's where it crosses on the x-axis. And a horizontal line going this way has a y equals equation, and so here's just y equals 3. So it will ask you about the equations for the asymptotes, and they'll be roughly like vertical ones and horizontal ones. Okay, so we are going to be graphing, and our base parent function, inverse function is 1 over x. And so if you just want to sketch a picture of that with me in your notes, because then we're just going to translate it a bunch, like we've done a ton before. Up, down, left, right, stretch, compress, all that stuff. But here's our basic parent one like that. Okay, and so our asymptotes actually would be, this one would be x equals 0, which is just the y-axis. Right, you get closer and closer to the y here, but never hit it. And then here we would have y equals 0, would be this line right here, which is just the x-axis. So this one kind of has weird asymptotes. They're just the x and y axis. Okay, throughout this lesson, they're going to talk about domain and range a little bit. All right, so domain is what is possible for the x values, and range is what is possible for the y's. So for this parent function, this might be a good test to see. Pause the video and see if you can figure out what is possible for x and what is possible for y. Okay, and so our graph for x, look, we can have x2, x of 4, x of 6, x of 5, all the way out here, and all the negatives like -1, -2, -3, -4, right? But we don't hit the 0, right? In fact, we get closer and closer to x equals 0, but never hit it. So our domain ends up being here is all real numbers except the asymptote number, which is 0. Okay, and for the range, it's very, very similar. It goes up and up and up, so we can get any y number up here, and we also go down and down and down to hit all the negative y's there, but we don't hit 0, right? So our range is going to be all real numbers except 0. Okay, so we're going to graph, and then they'll also ask you a little bit about domain and range, right? And hopefully this will be more clear as we do a couple more examples. So, draw another coordinate plane, or if you got graph paper, it's really good to use graph paper to help here too. Okay, so the idea is we have our parent shape, right, on the previous slide, looks like that. It's kind of centered on 0, 0. And now we're just going to shift. So you got to remember, like this -2 and +1, how do you think it shifts the center of the graph? All right, and I'm not going to spend a lot of time because we did this a ton in first semester. So the number on the back moves us up or down. So in this case, it's going to be down 2. Okay, the number with x goes left or right, opposite of what we think. So instead of +1 being right 1, that's actually going to move us left 1. Okay, so I'm going to go down 2, left 1, and this is going to be the new center of the graph. And I'm just going to draw 2 asymptotes because it's going to look just like this, except the asymptotes aren't the x and y axis anymore. We're going to draw them in centered on that point right there. Okay, so I just draw a big plus symbol there, and then my asymptote here, the vertical one, is just an x equals line, and it's crossing -1, so it's just x equals -1. The horizontal one is just a y equals line, and if we look, it's y equals -2. So those are my 2 asymptotes, and then I'm literally just going to sketch this same picture. Okay, so I'm going to imagine it, but now centered around this spot right here, and I'm just going to do my best to draw it in. I have a little bit hard time drawing on my pad here, but draw it so that it approaches those lines but never reaches those asymptotes. So it'll look something like that. Okay, so domain and range, again, I would pause and try to do it on your own. What is possible for x? What is possible for y? X is going to be all real numbers, except, right, if we look at this graphically again, we get closer and closer to -1 on the x-axis, but we never hit it. Okay, so it's going to be all real numbers except -1. Range, very similar, right? For the y-axis, we go all the way up and all the way down, but we never hit -2. So you can use your asymptotes to figure out the domain and range. So here, range is all real numbers except -2. Okay, one more example for you to try. One more of these ones. I got a couple of another type here, but give this a shot real quick. Okay, so we are gonna go, this 5 is gonna make us go up 5. The -2 is gonna make us go not left 2, but right 2. So I'm gonna draw a point there and then draw on my asymptote. Okay, so this will be an x equals line, and that'll just be x equals 2. That's the vertical asymptote. The other one's a y equals, the horizontal, and it's just y equals 5 is where it's crossing right there. Okay, so before I draw my graph, so normally my graph would look like this. It would be like right here and right here. But you got to think with this -1, what do you think is going to happen? Okay, so the answer is it's going to reflect or flip. Okay, and it doesn't really matter if it's the x or y axis because your picture will end up the same. Basically, this shape is going to be reflected to here and here. Okay, so I'm going to draw it with a different color, maybe red. So my final graph just got flipped into the other two quadrants so that it looks like that. And so my final graph here is the red graph, not the black one. All right, that's what the negative does. Okay, so domain and range. Again, if you haven't already tried them, pause the video. Domain is all real numbers except for 2. Range is going to be all real numbers. And again, I'm looking at my asymptotes. All real numbers except for 5. Okay. That's it for the basic graphs. The next part I want to talk about is what happens if this isn't a 1 or a -1. That's kind of the final piece of the puzzle. So I'm going to make a second video going over that part.